I'm Stephen Goodfellow, and welcome to my slideshow, The Big Bang Unravels. Amazing new observations by the James Webb Telescope and the consequences thereof, plus a little history about human behavior. Space is big. You just won't believe how vastly, hugely, mind-bogglingly big it is. You may think it's a long way down the road to the chemists, but that's just peanuts compared to space. By Douglas Adams and the Hitchhiker's Guide to the Galaxy. It can be very hard to conceptualize the actual volume of the universe, at least the observable universe. So I reduced everything down to a model that would be easily understandable. So think of a sugar crystal on your finger. So you can see down there on the lower right hand side, I've created this sugar crystal, which is actually representing the Milky Way galaxy. So that's our galaxy on our finger. So imagine that sugar crystal, our Milky Way galaxy, being about 100,000 light years across. Now, what I've done here is I've scaled everything down so the little blue man or woman you see sitting there or floating there is 70 feet away from what we call the event horizon. That's the furthest distance away that we can actually see anything. So imagine you're floating in space and all around you, no matter what direction you look, there's a reddish fog that prohibits you from seeing any further than 70 feet. I have a little aerial map down on the lower left-hand side showing the library in which I gave this presentation, and you can see the cars outside on the road, just to give you some idea of a scale. Now, I created this model so that as the presentation continues, you can appreciate some of the phenomena we're going to look at and put it into a perspective that's easily understandable. Some of the first early comments we have about their solar system are attributed to Aristarchus of Samos, who claimed that the sun was in the center of our solar system and the Earth, the planets, were revolving around it. And he was also supported the theory by Anaxagoras that the sun was just another star. Placing the sun in the center of our solar system was actually a huge conceptual leap because it's very easy to imagine yourself as being at the very center of the universe. And this is what most of the Greek philosophers did. They placed the earth in the center and everything else surrounding it. So, in many ways, Aristarchus of Samos is a huge hero. Sadly, the learned scholars of his time ignored Aristarchus because the optical illusion of planets performing epicycles in the night sky. To their minds, it placed the Earth in the center of the solar system, and that was an error that was not corrected for almost 2,000 years. Claudius Ptolemy. Ptolemy was the Einstein of his time. His third treatise was Astrological, in which he attempted to adapt horoscopic astrology to the Aristotelian natural philosophy of his day. The Catholic Church promoted his work, which included the only mathematically sound geocentric model of the solar system, and unlike most Greek mathematicians, Ptolemy's writings were repeatedly copied or commented upon throughout hundreds of years, both in the late antiquity and into the Middle Ages. Some of Ptolemy's lost work starts coming to light in the beginning of the Renaissance, when the nation states such as Genoa and Venice had rich merchants that were into collecting books. And here were these books in Arabic and in Greek, ancient Greek, that they couldn't read, so they would hire people who could translate the books into Italian or Latin so they could understand it. And one of the books specifically, his Geographica, was brilliant because it described both latitude and longitudinal lines with which you could find out where cities were. And it was discovered that you could actually find a ruin of an ancient city from the Greeks or earlier by using his latitude and longitudinal lines. So it was really an eye opener for the beginning of Western Renaissance. So, as far as astronomy goes, let's talk a little bit about the 2 millennia long scientific dark age. It cannot be emphasized enough. The decline of the golden age of Greek inquiry that had been a dawn of curiosity and igniting the first sparks of scientific method, this was extinguished, gradually being replaced by the pedagogical groupthink, eventually cemented into place within the straitjacket of religious dogma. And it didn't have to be this way. We can look back at the Antikythera device that was found in 1905 near the island of Antikythera. It turned out to be an amazing device from 200 BC, which had 27 meshing bronze gears. So it wasn't like they couldn't build the instruments in order to discern the exact orbits of the planets, but they had declined. They didn't do it. The Arthur Kessler in The Sleepwalkers refers to it as almost like a cowardice on behalf of this uh, civilization that was sinking down.
So let's the basic layout of the solar system. The planets closest to the sun move faster and the outer planets move slower, but they all go in the same direction. Apparent retrograde motion is when the planets appear to temporarily change the direction of their orbit. They don't change direction, it just looks that way from Earth. It's an illusion that unfolds over a matter of weeks or months. In this image, Mars was photographed every 5 to 7 days between October 2011 and July 2012. Once all the photos were combined by aligning the stars in the background, it appears as though Mars looped back on itself before continuing on its orbit. A retrograde illusion like this happens when we lap an outer planet like we do with Mars every 2 years, or when an inner planet laps Earth like Mercury does every 4 months or so. But for both Mercury and Venus, the illusion is hard to actually capture, since they're located on Earth's day side, not on our night side. When those planets are visible, it's only right around sunset and sunrise. But assuming you could see it, here's a diagram of how the Mercury retrograde illusion would work. This line shows our view of Mercury against the background stars. As Mercury passes us by, our line of sight shifts so that for about 3 weeks, Mercury will appear to loop back on itself when viewed from Earth. It's simply a function of two objects orbiting in the same direction at different speeds. If you stood on Mercury, you would see Earth make an apparent loop too. The key is to always remember that Earth is moving too. So retrograde motion was baffling to early astronomers who thought that Earth was stationary and at the center of the solar system. In the 2nd century, Ptolemy devised a complicated system of loops and orbits within orbits to account for the retrograde motion of planets. That model was accepted for 1,500 years because it seemed to fit the observations, even though it was completely wrong. Once Copernicus showed that all the planets, including Earth, move around the sun, then retrograde motion was easily explained as an illusion. So if there's any life lessons to learn from Mercury retrograde, it's that we may be vulnerable to illusions when we think that everything revolves around us.
And so geocentrism lasted for almost 2,000 years. It was only in the 1600s that a baron called Tycho Brahe, who had a scientific bent, decided to actually measure the orbits of planets, and specifically Mars. His instruments were in no way any better than what the Greeks had. He just had more curiosity. If he were a contemporary in our age, he would be considered a billionaire. You can't see it in this picture here, but apparently he had a silver nose. There's two possible reasons for this. One was that he lost it due to venereal disease, and the other was that it was bitten off in a brothel fight. As I said, he was amazingly wealthy, so much so he had a pet elk. Unfortunately, one day the elk wandered upstairs, found some beer, drank it, got drunk, fell down the stairs, and had to be put down because it broke its legs. And Tycho Brahe was inconsolable. This can be seen from a break in his records when he didn't do any scientific work for a period of time. His counterpart was Johannes Kepler, who was a brilliant mathematician. His initial tryout to see if he could describe the solar system within the five perfect solids, as you can see down here on the lower right-hand side of his image. It was a brilliant idea, and it was very popular, and many rich people had one of these structures or sculptures in their place of viewing for to impress their fellow rich people and everybody else. But Johannes Kepler realized that it was inaccurate, and he had the fortitude and the persistence to give up on the idea because Mars didn't fit in the orbit of one of the solids. So he went back to work on it. He got wind of and exchanged correspondence with Tycho Brahe, who had by then done the orbit of Mars, which didn't fit, and he started to see what could be done about that. But Tycho Brahe was not ready to give Johannes Kepler his data, and in fact held it quite close to his chest, so much so that uh, Johannes Kepler didn't get hold of it until Tycho Brahe passed away. And when he passed away, in under the guise of coming to give his respects to the family, Johannes Kepler came to the office of Tycho Brahe and stole his data so that he could go to work on the orbit of Mars. I would love to have been in the room when Johannes Kepler realized that the planets didn't do retrograde. What they did was travel in ellipses. And this is what gave the illusion of the retrograde action. His publication was foundational for the three laws of planetary motion, which lay fairly dormant for about 100 years until Isaac Newton came along and writing his Principia, that's his book on gravity, he wasn't a man for being very praiseworthy of other people, but he did say once, "If I have seen far, it is that I've stood on the shoulder of giants." And I have no proof of this, but my guess is that he was referring to Tycho Brahe and Johannes Kepler. And so now we're going to move ahead into the 20th century. This is a time when they're realizing that the cosmic redshift can tell us something about the distance that stars and galaxies are away from us, and also that background radiation is discovered and what this implication is for cosmology. I think one should always be especially alert when religion attempts to mix with science. Georges Lemaitre was a Belgian Catholic priest who was a mathematician and a cosmologist, and he realized that cosmic redshift must eventually sink into the extreme end of the spectrum. That would be the beginning of the universe, he claimed, a Big Bang, and in the beginning. And of course, the Catholic Church absolutely loved it. As a child in London, I often experienced the London fogs. And I never thought that when I couldn't see any further, that there would be a Big Bang surprise beyond the fog. To believe that there is a Big Bang beyond the event horizon, one must take a heaping measure of a suspension of disbelief, and can only be forthcoming if supposedly reliable cosmologists convince the public that it is so. In 1965, the Holmdel horn antenna was activated. While using this antenna, Penzias and Wilson discovered the cosmic background radiation that permeates the universe. And hand in hand with the cosmic redshift interpretation, this is supposed to confirm a Big Bang universe. Did any cosmologist stop to think that it might be a universal background radiation that is always there? Before the horn antenna discovery, several cosmologists attempted to predict a background temperature. Some calculated it would be 6 degrees, some said it would be 4 degrees, others said it would be 3 degrees. But when it turned out to be 2 degrees, they just adjusted it accordingly. Einstein mathematically predicted the anomaly of the orbit of Mercury, and his result was correct. He didn't have to put any band aids on it or readjust to make it work. And so we entered the 60-year era of the Big Bang. It was a sensation, a triumph of scientific deduction, not only to have discovered that the universe had a beginning, a dawn of time, but we could actually place a date of birth 13.8 billion light years ago, and it was expanding. For over 60 years, the Big Bang theory reigned supreme. And as with the Ptolemaic Earth centered system, the theory gradually became the victim of groupthink. Astrophysical journals rarely published any alternative models. The Big Bang reigned supreme. For the Big Bang to be viable, it depends on three major assumptions. One, the cosmological principle that on large scales, the universe is homogeneous and isotropic, meaning that it looks the same in all directions and from every location when averaged over a large enough volume. Two, expansion prediction, the increase in distance between gravitationally unbound parts of the observable universe with time. Three, general relativity as the correct description of gravity, providing a framework for how the universe expands and evolves. So, let us take a closer look at this. I'm going to include a personal note here. In 2018, galaxies were being discovered a scant 8 billion years from the Big Bang. Now, how could that be? How can something as gigantic as a galaxy containing second generation stars containing carbon be created in so short a time? For stars around one solar mass like the Sun, hydrogen exhaustion takes roughly 10 billion years before it fuses atoms into carbon. 2 billion years before a Big Bang. The galaxy's age must be older than the Big Bang. I posted this on a reputable physics chat board. The admin scoffed and removed my post, but for me, the damage was done. I waited and waited to see if there would be journal commentary about this. You could hear a pin drop. No one commented on this discovery. And I thought to myself, could it be that there was no Big Bang? Further cracks in the Big Bang model started to appear. The cosmological principle, you may recall, says that on large scale, the universe is homogeneous and isotropic, meaning it looks the same in all directions and from every location when averaged over large enough volumes. But it isn't. Enter the giant arc and the giant ring. These were discovered shortly before the James Webb Space Telescope activated. It's a size problem. Cosmologists calculated that gravity should have had enough time since the Big Bang to pull matter together into structures larger than about 1.2 billion light years. The giant arc is nearly 3 times that limit. It's a proximity problem as well. Not only are they too big, but they're neighbors. They sit just 12 degrees apart in the sky and at the same distance. This makes it statistically unlikely to be a rare fluke. If the universe were truly isotropic, we shouldn't see such a massive concentration of matter in one specific clump while other areas are empty. Imagine if a cosmologist was a milk inspector and he told you that it was perfectly safe to drink the milk because there were absolutely no clumps in it, and you drank it and you realized there were two big gooey clumps in it. Would you have confidence in that milk inspector? Da 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 da. And then in 2022, the James Webb Space Telescope took its first deep field images. A couple of weeks before the James Webb Telescope opened for business, I was on a university radio broadcast and I confidently predicted that when the James Webb Telescope looked at the deep field sky, they would see normal galaxies and countless of them. Let me tell you, it raised some eyebrows because everybody was expecting small, unformed primordial galaxies the closer they were to the Big Bang. Now, I didn't believe that because I had done my homework. In 2018, I saw that article and I believed it. Apparently, no one else took notice of it. So the James Webb Space Telescope took its first deep field pictures and it saw lots of mature galaxies right up against the Big Bang. And as you can see from my little cartoon here, the vast majority of cosmologists were utterly surprised. Shame on them.
The tenets of the Big Bang, that the universe started out small, hot, dense, where matter and energy were a primordial soup, where the forces of nature had merged. All of that is thoroughly supported by observations of this universe. Thoroughly supported. Okay? Now, there's some things that, well, did this really cause that? Or might it be something that we don't know about yet? Here's the point. If tomorrow you have a new idea about how the universe works, it's going to enclose everything we've been talking about up to that moment.
That we're surprised. Just put that out there.
All right, you said rethink what's going on back there. So what's the rethinking? What are you thinking now, having gotten this new information?
I don't know.
Wait, you're the astrophysicist and you don't know? That's why we have you here, Neil deGrasse Tyson.
The whole point of doing research on the frontier is you're stepping into places where no one has stepped before. Right. The whole concept of the James Webb Space Telescope was to see the universe the way no previous telescope had ever seen it. So some things you'll verify that you expect to be there, but you also expect to make discoveries that nobody ordered. And then, we got to go in and say, what's going on? And there's nothing wrong with not knowing. Okay. This is part of how we live.
All right, well, let me tell you, this is one of the co-authors of this study said, and this is in a statement, and I quote here, it says, "It turns out we found something so unexpected, it actually creates problems for science. It calls the whole picture of early galaxy formation into question." So again, go on.
Just to be clear, okay. So let me reword that. Okay, I respect how that's stated, but let me reword it. You discover something new. It doesn't create a problem so much as it creates excitement. A new understanding of the universe. We delight in this. It's not like we're all sitting back with our legs up on the table saying, basking in the knowledge of the universe that we have command over. No, we are always at the drawing board. And to people say, scientists will have to go back to the drawing board, we're always there. If you're an active research scientist, that's where you live. And you are befuddled daily.
Dark Ages.
Our universe entered a literal dark age.
This is the cosmic dark ages.
The universe was plunged into the dark ages.
The universe had just entered the era known as the Dark Ages.
Okay, so let us start looking at the hard data that pertains to the Big Bang and see where it follows. We'll start with the Dark Ages. This is an area right after the Big Bang that was supposed to only consist of primordial particles, absolutely no galaxies, no stars. So what does the data say? The expansion prediction was supposed to demonstrate the increase in distance between gravitationally outbound parts and the observable universe with time. The present interpretation of cosmic redshift was a predictor of a dark ages, a means with which to look back into the evolutionary past. This was an error. This means that our interpretation of cosmic redshift is false, yet this fact does not seem to have had any impact on the majority of cosmologists who continue to unabashedly use it as if nothing is amiss. What the absence of a dark age shows is that using cosmic redshift as an evolutionary measuring stick is explicitly wrong. What the absence of a dark age and the giant ring and giant arc demonstrate, there is no evolutionary process that we can recognize by using cosmic redshift.
Another prediction from the Big Bang is that galaxies in the early universe should actually look larger due to the expansion of the universe. This might sound a little counterintuitive. The size you perceive an object to be normally only depends on its actual size and its distance from you. In the Big Bang, the universe is expanding. Add into this that they now also think this rate is accelerating. So if we imagine an object that emits light from 2 points, if the universe was static, the angle you saw the light separated by would directly relate to the distance between them and their distance from you. But if the universe is expanding, you need to take into account the fact that when the light was originally emitted, the universe was much smaller and hence took up a greater proportion of the universe's scale than the object would now. This means that if the Big Bang is correct, then as we look at older and older galaxies, they should start to appear larger and larger. So what is the James Webb Space Telescope revealing? Smaller and smaller galaxies. Even galaxies with greater luminosity and mass than our own Milky Way appear in these images to be 2 to 3 times smaller than in similar images observed with the Hubble Space Telescope. And the new galaxies have redshifts which are also 2 to 3 times greater. This is totally against the idea of an expanding universe, and means that these distant galaxies must be extremely small to compensate for the expansion illusion. And by small, this would imply implausibly small. As an example, GHZ2 was identified in one of the papers published. It is far more luminous than the Milky Way, and yet, based on their calculations, is only 300 light-years in radius. This is 150 times smaller than our Milky Way. To put this into context, this would make it 600 times brighter than the brightest galaxy in our local universe. This puts its density at tens of thousands of times that of the present-day galaxies. With fewer or no mergers, there is no way tiny galaxies could grow up to these high-density beasts.
So let's compare the Big Bang against actual data. The Big Bang, massive objects too big, galaxies too mature, distant galaxies are too small. So now we know that the universe is not isotropic nor homogeneous, the condition that's necessary for the Big Bang, because the giant arc and the big circle are too large to have formed in the time allotted to them after a supposed Big Bang. Then there are the fully mature galaxies that inhabit what was supposed to have been the Dark Ages. If we treat the distant galaxies as line of sight, then we don't have to get into extraordinary, unusual physics in order to make the Big Bang possible.
First, the James Webb Space Telescope revealed something unexpected. Massive, fully formed galaxies appearing far earlier than predicted. some just a few 100 million years after the supposed Big Bang. This shouldn't be possible. There simply isn't enough time in the Standard Model for galaxies that large to form by then. So, cosmologists introduced a fix. Perhaps these galaxies formed incredibly fast, with extreme star formation rates and a skewed population of massive stars. A top-heavy initial mass function. That patch worked, at least on paper, but it did have a side effect. More stars forming faster means vastly more radiation. The radiation, reprocessed by dust and redshifted by cosmic expansion, created a diffuse background glow. And, according to the new paper, the total energy of that glow could match the cosmic microwave background, the CMB. In other words, the fix for early galaxies created a new source of background radiation, and that source could be strong enough to account for the very signal we've been calling the relic of the Big Bang. So now we're stuck in a loop. JWST sees early galaxies, model breaks, rapid formation is assumed, increased radiation, explains the CMB, but the CMB is used to anchor the timeline that defines what counts as early. It's circular. The solution to one problem becomes the foundation for another, and the line between cause and consequence disappears.
So, with this barrage of new information and data streaming in, can we assume that the cosmologists are going to abandon the Big Bang? Well, no. Most cosmologists have committed their careers to supporting the Big Bang theory. They've invested an enormous amount of time and effort in gaining status from published papers and profit from writing books. One has to remember that even after Newton's Principia, it took decades for the geocentric model to be discarded. One must always remember the human factor, even in science. So, as you can see, I've listed here a variety of alternative universal theories that are for you to explore. Do I have a horse in this race? Not really. It's just the data that interests me. If I had to, if you prodded me, I would say, well, imagine if you were one of these little cells in the back here. This is a blue-green algae. Imagine that you were intelligent, an intelligent race lodged in one of these blue-green algae, and you looked out upon an ocean universe, and you could maybe see like an eighth of an inch away from you. Well, that wouldn't give you a lot of scope. You'd see a few things, and like we see a few things in our universe. And of course, the blue-green algae is part of the ocean, which is huge. And then there's the continents. And then there's the planet. And then there's the solar system. The solar system is going down the galaxy. And then we have the group of galaxies, and on and on. And if you go in the other direction, you come down to the atomic structure, you're dealing with smaller and smaller elements of what the universe is made of. And maybe it's infinite in that direction. I don't know. I just find it fascinating to speculate on, and I'll leave it at that. Thank you for taking the time to watch my slideshow. I'm Stephen Goodfellow, and I hope you have a great day.